Hi there, I'm Peter, Managing Director of Glass Curtain. We're a Canadian manufacturer of fiberglass framed curtain wall systems for triple glazed applications. And today we're going to talk about combustibility. Life safety is an area of design and construction that deserves a lot of attention. Buildings are our shelter and protection, after all, so we need them to be safe, even when the proverbial lightning strikes. And when it comes to fire safety in particular, the National Building Code of Canada is amongst the most stringent in the world. This obviously brings about benefits for our homes, our places of work, our places of study, our places of leisure, but it does bring about occasional challenges for manufacturers, especially those at the more innovative end of the spectrum. That is, those doing things a little bit differently than we did in, say, the 1970s and earlier, when most of the fire codes in particular were written. At Glass Curtain, of course, we wholeheartedly believe that life and safety are paramount. And the Building Code of Canada is mostly rational in achieving this aim. But it also has newer and increasingly stringent energy efficiency and thermal performance objectives. And these can be at odds with other, older sections of the code. So how do we square the circle, given that fiberglass materials in general and our thermoset polyester fiberglass reinforced polymer mullions in particular are considered combustible when used in an exterior window application? While we won't dig too deeply into the problem of even defining combustible in a world where conventional aluminum frame curtain wall systems are required to use, by the Energy Code, combustible polyamide breaks at the exterior or in the center of the glazing line, the National Building Code of Canada makes exceptions and a path to acceptance for building products that can successfully demonstrate their ability to limit the severity and effect of fires, the details of which are outlined in sections 3.1.5.4 of the National Building Code of Canada. But the essence is basically this: pass CAN-ULC S134. So what is CAN-ULC S134? Well, I'm glad you asked. Designed around a 3-story assembly, the CAN-ULC S134 test is designed to simulate a real-world scenario that tests the worst-case scenario in the event of a fire. This test is specifically designed for claddings and curtain wall systems. With a 2.5 meter by 1.4 meter blazing inferno designed to simulate a broken window partway up a multi-story building, this rigorous and hugely demanding test starts with a 20-minute fire in the combustion chamber. The fire is then turned off after 20 minutes, and the cladding or curtain wall material then has to self-extinguish completely after a further 20 minutes. Passing this test also requires that flame spread height and temperature flux tests also be passed. Heat flux capacitors are placed throughout the assembly and cannot pass very specific thresholds for the duration of the test. For any one of those heat flux capacitors to exceed their threshold is an immediate failure in the test. As well, in terms of flame spread height, 5 meters is the limit that the flame can reach. And this distance is measured from the top of the combustion chamber. All of this is designed to ensure 3 things: that our brave firefighters have enough time to extinguish a fire, that occupants in higher floors have time to exit the building, and that the building structure itself is protected so as to limit property damage. As you can probably tell, this isn't an easy test to pass. So it was a very big deal when in 2018 we passed with our Therm 134 system. Glass Curtain designed, engineered, fabricated and installed this assembly, this mock-up, at the Intertech facility in Texas. Having passed this rigorous test, we've become the first curtain wall manufacturer in North America to do so. Using a special resin matrix version of our standard Therm fiberglass framed curtain wall system, our Therm 134 system scientifically and categorically demonstrated compliance with CAN-ULC S134, one of the most rigorous fire codes in the world. With the funding support of Alberta Innovates, we achieved what had long been a dream of ours, and what had long been a dream of many in the industry: to see an ultra high performance, 100% Canadian curtain wall system manufactured and suitable for use in buildings over 6 stories tall, as well as other buildings, of course, requiring non-combustible envelopes. For architects and designers looking to specify Therm 134, obtaining an alternate solution under section 3.1.5.4 couldn't be easier. With the adoption of NBC 2020, it's a matter of a short form, thanks in no small part to our allies in fiberglass windows, and you know who you are, and the support of Natural Resources Canada, or NRCan. Demonstrating compliance with CAN-ULC S134 has never been simpler nor more straightforward. So that's combustibility as it pertains to fiberglass framed curtain wall systems. As ever, where there's a will, there's a way. And with the successful completion of CAN-ULC S134, our Therm 134 system gives architects and designers an R7 Plus option that can be used on any building type, including those requiring non-combustible envelopes. That's all for now. Feel free to follow us on Instagram and Twitter @GlassCurtain, or through our website for our blogs. The links for all of this will be in the description below. Thanks very much. We'll see you next time.